Hi, I'm Don Dooley, President of Spectrum Detector. We prepared a short demonstration video on one of our Delta family digital laser energy meters. Probe model DPJ-8, which features a pyroelectric detector, and Delta DPM digital power module. Before we get to the demonstration, let me tell you a few things about the Delta products. The Delta DPM comes with versatile full-featured LabView application software and supports either single or dual channel operation. Select from a wide range of energy probes that include either silicon, germanium, InGas, or pyroelectric detectors, and range in active area from 3 millimeters to 25 millimeters. Measure pulse energy from femtojoules to millijoules, and from 1 pulse to 1500 pulses per second, and measure pulse widths from femtoseconds up to 10 microseconds. Now let's get started with the product demonstration. The Delta energy probes are small, compact. They include a detector, an integrated preamp, and an EEPROM where we store the calibration and wavelength correction data. The housing includes a Q20 and M6 threaded post hole, as well as an SM1 threaded front bezel, which makes it very easy to add optical accessories like an ND filter. Just screws onto the front. The assembly also includes a shielded cable with a locking Amphenol connector. The Delta DPM includes the microprocessor, A to D converter, digital electronics, and a USB connection. The box has a USB connector on the front. This is a green power lamp. It's on when the instrument is powered up. Includes a BNC analog voltage output, 0 to 2 volts, and the mating Amphenol connector for the detector. Before we get started on the demonstration of the software, let me walk you through the optical setup here. We have the DPJ-8 pyroelectric Joulemeter probe, the Delta DPM power module, an ND filter wheel, the neodymium YELF laser head, the pulse laser controller, a digital scope which we use to display the analog output from the DPM. Now let's go ahead and show you how easy it is to set this up. Just take the detector cable, align the 2 red dots on the Amphenol connectors, push it together. Take the BNC cable from your oscilloscope, attach it to our BNC, take one end of the USB cable into the USB connection on the front of the Delta DPM. You'll see the power light will come on, and that of course assumes you have the USB connected to your PC. Now let's go ahead and bring the software up. We'll assume you've already downloaded the software, and there'll be an icon then on your laptop. Click on that to bring the software up. So the window here would normally display the energy says wait as it's going through initialization, and it's pulling the data from the EEPROM in the head. Pretty soon we'll be reading, we'll be able to click on the data collection button right here, and we're now reading pulse energy, about 87 microjoules, and we're displaying a 50 pulse data set on the strip chart. And you can see up here we have a nice clean analog voltage output from our probe. Now we're ready to take a close look at the SXI Delta LabView application software. This is revision level AM. This is the control panel, which is always visible to the user. In the upper left hand corner is a large window where we display pulse energy in real time. We're reading about 87 microjoules right now. Just below that are 4 windows where we display the calculated statistical data set: min, max, mean, standard deviation. Up in this right hand corner is the data collection button. This is how you turn data collection on and off. Just below it is a log to file button to log data to a file on your computer, and this window actually shows the file we have open to which we log the data. Now moving below this area, we get to a couple of the controls. This is a range switch, basically. You click on that and you can manually range the instrument from 2 microjoules to 20 millijoules for this particular DPJ Joulemeter. To the right of that is a trigger window. This allows the user to set the trigger anywhere from 2 to 20% of full scale. We're set at 5 right now. Moving down in the lower part of the display, there are annunciators, status annunciators here. There's a window that displays the RV of the probe in volts per joule. There's a wavelength window that displays the wavelength that we were measuring at, which is in nanometers, 1047. There's a trigger annunciator, which should be green if it's triggering properly. Just below that, there's a frequency and range annunciator, which should also be green. It means that we're within the 1 to 1500 hertz frequency range capability of this instrument. In the lower left-hand corner is a window that shows the actual frequency that laser is running at. Right now, that's 20 hertz. Now let's move to the right underneath the strip chart. This is where the user will set the method of collecting data. You can, in this window here, it's called sample collection, you can set fixed or continuous. In the fixed mode, you're actually going to set a batch size. We've set a batch size of 50. You can reset that manually or use auto reset. Right now we're in the auto reset mode, so it will update every time it gets 50 pulses. There's also the continuous mode. When you click on that, it's going to measure every pulse until you stop it. The batch size no longer means anything. There's a collection mode, which is either streaming or time interval. Streaming is the way we're using it now. If you wanted to set a period of time to take data, that allows you to do that. Now let's look at the 4 screens that are available as part of the software. The first one is the strip chart. This is where we plot pulse energy per unit time. So we're looking right now at the 50 pulse data sets displayed in an auto scale mode, so it's maximizing the resolution. We're reading from 87 down to about 86 microjoules. You can take auto scale off. Now you're going to read about 87 microjoules on a scale of 0 to 200 microjoules. The next screen is a histogram. In this screen we're showing the data in pulse energy in bins. The user can actually set the bin size using this box up here. Tuning mode. This is a convenient analog tuning screen that allows you to tune the laser or peak your laser when you're setting things up. Here I'm putting an ND filter in the laser beam. You can see the readings changing and you can see the needle moving back and forth very rapidly. The blue needle is the minimum reading, the red needle is the maximum reading. And the actual readings are displayed to the side here. The next window is the setup window. Very important because this is where the user, set the wavelength at which you want to measure. This window here allows you to go in and set the wavelength. We're set at 1047 nanometers now. When you change the wavelength here, the wavelength correction factor changes. Right now it's 1. The window to the right of that is the transmissivity window. This is where you set the transmission loss factor basically for an attenuator if you're using an attenuator on the probe. The window next to that is where you set the diameter of the sensor or the diameter of the laser beam. If you want to measure in joules per square centimeter, you then just click on this button and you can change the reading to fluence. There's also a very handy auto set button. It's like the auto set on an oscilloscope. When you're just setting things up initially, you can get your laser running, line the detector up, and then hit auto set. It will automatically look for the appropriate range and trigger level to start this instrument working. Well, this brings us to the end of the demo for the Delta Energy Meter product. If you have any questions, please don't hesitate to call us. Thanks for joining us.